Hi Zach, I wish you're okay. In this video, I'll be covering some of the basic concepts concerning motion in one direction. Um, Although you may be aware of some of these concepts, but it will also deepen your understanding and will make you able to answer some of the problems we have. I'm also sending you some pages from Pearson so you can choose what suits you to answer, and we will be discussing these problems when we get online, inshallah. And also, if any of your friends need help, you can share this video with him. So I'll begin directly. No, I'll begin with the first slide. Yeah. Okay, talking about motion in one dimension. First of all, I'm gonna state some differences between concepts like the scalar and the vector quantities. Actual scalar quantity is a quantity that cannot be negative. Quantities like time, like mass, like distance, all of these quantities cannot be negative because time will not go back and mass will never shrink until it increases in the negative direction. So these are called scalar quantities that have only magnitude and doesn't have direction because it's always in positive. But on the other hand, we have the vector quantities, which have magnitude and direction, and based on the direction, it can be positive or negative. So positive or negative signs indicate the direction of these quantities. And examples of the vector quantities are displacement and velocity, and we'll be covering these concepts in a minute. Okay, distance and displacement. The difference between distance and displacement, that distance is scalar quantity and it's every change in position. Every change in position covered by an object is called a distance. But displacement is just the difference between the end position and starting position of an object. So it's basically a vector quantity and can be positive and can be negative and also can be zero, while distance covered by the object can be let's say 5 or 6 or 7, but vector quantity can be zero in some cases, like moving in a circle, because moving in a circle makes you end at the starting point. So the difference between displacement will be zero. So distance not necessarily equal displacement. Okay, moving to the next slide, speed and velocity, and depending on whether you are dealing with displacement or distance will be the term speed and velocity, because speed and velocity are all rate of change, but speed is the rate of change of distance because it's the change in distance per time interval. And this makes it a scalar quantity because both distance and time are scalar quantities, so speed is a scalar quantity which is always positive. But velocity is the rate of change of displacement. So as long as displacement is a vector quantity, so it can be positive or negative, but time is always positive, so we will have velocity as a vector quantity that can be positive or negative depending on the direction, and it is stated as v equals delta x over delta t, while delta x is the difference between maybe displacement and maybe distance, and delta t is the difference between time, which means time interval. The term v without an arrow on it means distance, but if we have an arrow on the v, it means displacement. Okay, here we're talking about the average velocity and average speed. and average velocity is the total change in displacement through certain time interval. So uh, v average, and we write the average velocity as v av, abbreviation for average, equals x2 minus x1 over t2 minus t1, which means how much displacement do we have over how much time it was covered in. And average speed is the same, but dealing with the changes in distance instead of displacement. And average velocity is very easy because it measures the total difference between the two positions, and it's different from the instantaneous velocity that we'll be covering in a minute also. So the main difference between the average velocity and average speed is average velocity is dealing with displacement, and that the speed is dealing with distance. Okay, here we have a problem. Calculate the average speed and average velocity of a complete round trip in which the outgoing 250 km is covered at 95 km per hour, followed by 1 hour lunch break, and the return 250 km is covered at 55 km per hour. So here we have an object moving in a round trip, and round trip means that is a circle. So it was going with 250 kilometer. It covered 250 kilometer with the speed of 95 kilometer per hour, and then followed by 1 hour lunch. So meaning that it was in the end position for 1 hour, and then it returns 250 kilometer also at 55 kilometer per hour. So how are we gonna deal with this problem? Okay, first of all, we need to state that the average speed. Let's first talk about the average speed. And average speed is the difference in displacement over the difference in time. So we have to know the total. The total distance over the total time. So we must know the total distance and the total time. And let's move so we can just try it on here. Okay, I'm finding my stylus. Okay, I don't know if it works. No. Okay, yeah. Okay, so let's plot these values. Okay, 250 kilometer. This value 250 is displacement. So we're gonna is a distance. Sorry. So we're gonna state it as x1 equal 250. So delta x1, because it is a difference in distance, so delta x1 equals 250, and covered at 95 kilometer per hour. So we're gonna state this as v1, because this is a speed. So v1 equals